Hello, 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 hello. I have another uh, case, and this motherboard is not charging battery. It's working with the charger and it's working with battery. The board will work with battery, but the battery will not be charged. So as long as the battery loses its power, then that is the end. Even though you connect the charger, or the battery will not just charge, and that's the case. And this is the brand new battery. The owner thought the battery is the problem, and the battery is not even the problem. The problem is from the motherboard itself. So you can see, you see it's the charging indicator shows like it's charging like normally, but it's not taking any amps. This is my power supply. You can see 19 voltage, and the current, that's the power. Normally, when laptop or mobile phone is charging, of course it's taking some arm, and normally the arm supposed to be at least one arm up. Is only maybe the battery is getting full, so the arm will be reducing. But this is just normal standby power for most laptop, like normal standby power consumption. So before I will go deep, before I will start to repair this board, I would like to explain uh charging circuits on motherboard, how laptop charge, how charging work on motherboard, or on laptop motherboard. Mostly the concept is more like the same thing on most laptop, only few different, and that's just it. But the basic, they are based on the same concept, and that's so. i will I would like to explain that first, then I'll come back to this motherboard, then fix it. I will try as much to focus on the most important components, just to reduce the length of this video, because I want to keep this video as short as possible, but I will try to include the most important components. So first of all, let me assume this is charging ports. We have our positive here, and this goes to ground. This is our negative, which connected to ground. So we will not focus on this. We just, because of course it's connected to ground, every other negative side will also connected to ground, so we just focus here. So this is 19 volts, or any footage. Normally we have charging port here. We have a MOSFET, and we have another MOSFET. We have charging IC here. We have let me call this battery, and this battery have a positive terminal here, and negative side here. And another thing, we have IO controller, which is the power controller for laptop. So this is the IO charging IC, and this is battery. So basically these are the major components that control the battery charging of a laptop. There are other things, but I will just focus on the most important one. Now 19 volts, it will comes to first MOSFET. We have 19 here, and this first MOSFET, if you know how MOSFETs work, you know the source and the drain and the gate. The source is where the voltage enter, and the drain is where is the source is the entrance, and the drain is the exit. So but this entrance cannot cross over to the exit without the without gate. Like normal, you wanted to you enter somewhere and you want without, you have to pass through entrance, and that is, let me just use that word. So these 19 volts at the charging ports, there is a link that's connect to the charging IC from the 19 volt before the first MOSFET, and they will use different name for this pin on the charging port, but mostly they use AC detect, that is AC detect. Another pin, let me use this one too. It depends. Some will have gate here, while some will have their gate here. It depends on what they use, but let me use it here. This gate is driving by the charging IC. The gate of these two MOSFET is driving by this charging IC. When this charging IC detects AC, then after other requirements have been met, so the charging IC will open this MOSFET to allow passage of voltage. Then it will enter the second MOSFET here, then come out of the second MOSFET here. Here too we have 19 here voltage, and we have 19 voltage here too. So another thing, there is a resistor here, CLR, current limit resistor. Let me call it CLR. That CLR, this charging IC will have connection with it from the inputs of the resistor and the outputs of this resistor. Those two pins are very important, because the charging IC uses it as ammeter. That is what this charging IC used to measure the amps flowing into the laptop. So this charging IC also send a signal to IO. This pin can name different things, AC in, different, but AC in is more common, it's more commonly used. AC in, to let the IO knows that this laptop is working on charger, and there will be a data communication between charging IC and IO, that is clock and data. Clock and data. Also, this IO, there will be another data communication between battery and IO. This is another clock, another data. Now, as there will be outputs here, which is the main charging output, the main charging voltage for the battery. This will, there will be two MOSFETs, one connected to ground and the other one connected to 19 voltage, mostly through this CLR, mostly, but in some cases it may not be directly connected to the CLR, but mostly through this CLR 19 voltage. And these two MOSFETs have their gates controlled by this charging IC. They have their gate control by this charging IC. So these two MOSFETs, they, to me, basically they form voltage divider. And why they didn't use the normal voltage divider, because this thing is working on various voltage. It's not a static voltage, different voltages, because the thing depend on the battery voltage. This thing have to switch to match the right voltage just to keep the battery charging. So and that's it. So it's working on different voltage, assuming if this battery, what's the voltage of this battery? Okay, this battery is working on 14.8 volts. Assuming this battery is below maybe 11 voltage, this output will adjust. Maybe it will add like 6 voltage to the 11 voltage, just to keep, because the voltage have to be more than the battery voltage for the battery to charge. Normally, for anything, if you want to charge battery, you have to increase the voltage more than the battery voltage for the battery to charge. So normally that is how it's charging work. So this will pass through coil. Let me use it like this, coil, then straight to this battery plus terminal. And another thing is, we have another another MOSFET here. Let me do this. Okay, MOSFETs MOSFET. Another MOSFET and this MOSFET is also controlled, the gate is also controlled by charging IC. Mostly they call it battery drive, or but they can use different name, but the gate is controlled by this charging IC, but drive, something like that, bat drive. So when we remove charging IC will enable, we drive this MOSFET, we call it discharging MOSFET, that is battery discharging. It will allow voltage on this battery to come through this resistor, then to the main power source. Sometimes they call it PR, something like that, I think so. Power source, that is the main VCC terminal. It will allow it to pass. When there is charging IC will stop driving this, so the battery voltage here, probably let me use this 14.8 volts, it will stay here, then we have 19 here. Normally we have 19 here. If when we plug charger, if we remove charger, the battery voltage will cross over to this point. If we have 14.8 or 15 or any voltage on the battery, we have the same voltage here, and we have the same voltage here. So you can see all these components that are involved in laptop battery charging. We have the battery must be okay. We have IO, the communication between the battery and the IO, then the communication between the charging IC and the IO must be okay too. All this AC in, AC detect, battery drive, everything must be okay. So we have a lot of things to check, and that is why charging problem is mostly difficult to repair for beginner. Even though sometimes we'll check all these footages, all these things with multimeter, and we'll have the correct footage, but in some cases those footage are not really okay, because if you check it with DSO, we will find out some frequency, and we don't need frequency there. And also all this data communication, we cannot check it with multimeter. We need DSO to check the communication, if the thing is actually communicating. So now I will check this motherboard and see where we have problem. And basically this is how laptop charging work. This is how they work. You can find different names, you can find things. And another thing that I did not include in this diagram is the LED circuit, the protection circuit, over current, over power protection. All those things are, I just left those things for some time, because I know it's not the major thing. Of course, if there's a problem there, our laptop may not even work at all, or the battery may not, stuff like that. But those ones, they are aside. Mostly these are the main thing. Okay, you can see. Now I've plugged the charger and the battery, and it's not taking enough power to charge the battery. It's not taking enough power to charge the battery. So I will start the troubleshooting now, checking one by one from the DC jack. Of course, I know since the laptop is coming up, I know the DC jack is okay, and at least the power is reaching some point. First, in cases like this, I would like to check, or let me just say it's advisable to check battery terminal. Battery terminal, on the battery terminal we have 15.6, which is, I think that is battery footage. That is battery footage. Removing the battery, what fault? 5.5. Cool. 5.5. Like I said, the footage is maybe around 6 foot or something like that. So just make sure the footage is more than the battery footage. Now let me open the schematic. This is the schematic. From the DC jack, from the charging ports, we have 19 volts. This is the first MOSFET, PQ36, and this is the second MOSFET, PQ37, and this is the power source. This is the main source, the main power source for every component that is connected to main VCC, which is 19 volts. This is where everything comes together. Every one of them must have connection to this point. So what else now? To make it short, I would like to check the gates of these two MOSFETs. Normally if the gate is not working at all, there's no way we will have footage here. There's no way. Or this is the CALR, that I'm current limiting resistor. There's no way we will have 19 footage here. But as in some cases, the gate is not switching properly, and that can make the troubleshooting easier for you to dictate. Like, it's like, oh, because that will just give you some sense like something is actually wrong, and it will help you to quickly go to the main problem. Let me go back to the schematic, and this PL9 is the output, is the charging output from the charging IC. This is the footage that is charging the battery. You can see is going to the battery, is the battery charge. That is the battery plus terminal. That is where this footage is going. So normally we're supposed to have footage here. Is either from the inputs and the output of this PL9, and this is the PL9. PL9. This is PL9. You can see PL9. PL9. Cannot see it. I have to PL9. This is the PL9. you have 5 volts, and that 5 volts is not enough. Now let me plug the battery and see. 15 volts, we only have the battery footage there. We don't have a boost, we don't have the required charging footage. We only have battery footage there. It means the charging IC, or the charging IC is not charging the battery. Now this is the charging IC itself. PU1, you can see PU1, PU1, PU1. You see, that's the charging IC. And one thing we will focus here is the pin 15 and the pin 18, then pin 17. This 18, 15 and 17, this pin 18, which is I drive, is the pin that is driving the gate of the I side MOSFET. That is the MOSFET that is connected to 19 volts, and this low drive is the pin that is driving the gate of the low side MOSFET. That is the MOSFET that is connected to the ground. These two gates must be active, and this 17, that is the boost. This is the charging footage itself. This is where the charging footage actually coming out, because you see this phase, that is a phase. It's just like how the charging IC is monitoring the voltage of the battery, and this boost have a connection to that. It knows how many volts the battery have, then it know how to adjust how many volts it need to add up for the charging to okay. So we'll check this 18, 15 and 17. And 17. You can see the last pin from this side. Oh, let me check this. I have to, because of the multimeter, I have to. Okay, the last pin from this side is 20, then 19, 18. Carefully, 5, 18, 17, And we have 20, 19, 18, 17. 17 and where is it? 17 and 15. Where's 15? Think this is 15. Nothing. Nothing. You are checking 18, 15, then 17. 18, 15, and 17. And 17 is the boost, that is the charging footage itself. Is 20, 19, 18, high side, 15 volts, 15 volts, right? 20, 19, 8, and the following pin 17, 15 volts, 15.4 again, and 15. Nothing. Nothing. Okay, let's come here. We have 15 footage here. We have 15 footage on the pin 17 as well. Of course, we can have 15 on pin 17 because this is battery footage here, and it's coming. Nothing can stop. Nothing will stop it. It's coming back straight to this phase, and you can see this is only capacitor, and nothing can stop it. Yes, we can have it. We can have 15 here, but here 18. This I drive, we are not supposed to have 15 there. We are not supposed to have battery footage there because that 15 is battery footage. This is 19, which is the charger footage, and this 15.5 or something we are getting, that is the battery footage, and it's not supposed to come to this pin 18. Fine, that one is a question which I have to check. I have to suspect the charging IC, but before I will conclude, I'll check other pins as well. This is AC drive, and that AC drive, like I said, is the pin that is driving the gate of the of these two MOSFETs. Then AC present is the pin, is the signal that is going from charging IC to IO. Let me see if we have footage there, which is pin 5. Pin 5 supposed to be here. Pin 5, this is pin 5. We need something here. Yes, we have footage there. 2.7 is okay. And if you want to ask how we have that footage, because of course this pin 5 have link with this pin 16, and this pin 16 we have 6 footage there, and this footage is LDO. This charging IC generate that 6 footage within itself, and that 6 footage come through this footage divider, which is these two resistor PR11 and PR10, one connected to the 6 footage which come from 16, from pin 16, and the other one connected to ground, and in between it, that is where we have this AC in, which goes to the IO. So this pin 5, this AC in is okay, and uh other pin like this VCC pin 20, that is the VCC for this that is the main power input for this charging IC. Without this pin, without this signal, this IC will not work, and it's coming straight from, where is it, VAD. I think this is VAD. It's coming after the first MOSFET. This is VAD after the first MOSFET. That is where the signal is coming. And of course, I know where is the pin 20. Let me check. Pin 20. I'm sure we have it. Pin 20. Pin 20. This is the last pin. Yes, we have it, which is good. Now, before I will do anything, this is the clock and data between the charging IC and the IO. I cannot check that with multimeter, but I'm sure I can only check if we have footage there, because normally we're supposed to have 3 footage or 3.1 or 3.2 there. If you have that footage, at least we believe that, well, there's a connection. We are not sure if there's a communication, but at least there's a connection. So I will check those 2 pins, pin 8 and 9, and on the battery connector too, I'll check the clock and data there, at least if we have connection there. I cannot check the communication, but at least I can check the connection. So pin 8 and 9 on the charging IC, I'll check that too. Oh, okay. I'm having issue with one of my camera, but I will just keep you posted and let you. Pin 8 or 9. This is 6, 7, 8. 8, yes, 3.1 and 3.1. Yes, we have connection there, 3.1, 3.1, which is good. And on the, we have 3.1 on pin 8 and 9. Then the battery connector, that is pin 3 and 4. You can see SM data, SM clock, 3 and 4. This is 1, 2, 1, 2, 3 and 4. 1, 2, 3. Yes, we have 3.1, and we also have 3.12. So the clock and data both on the battery and the charging IC, there is a connection there. So now what I will do, I will replace the charging IC, because we are not supposed to have battery footage. We are not supposed to have battery footage on this pin 18, which is the I drive. It's like the charging IC have some internal shorts. It's short internally, and so I will remove this IC and replace it and see the result. Okay. 738. I'm sorry you can't see it very well, but the chip is BQ738 and yes, BQ24738, but they short it 738. Yes, BQ738. So I'll remove the chip and replace it. And yes, okay, this one is 738. I don't even know it. 738. Listen, I only need to take note of the position. Where's the position? Okay. Position. Yes. I'll remove it now. This and this. Separate out. Okay. So you have to check all the required signal before you can conclude, before you can even make attempt to remove any component, because removing a component without verification, or one, you can lose the chip, different things, so you just need to confirm before you remove the chip. Okay. Let me remove this one first. Okay. It's out. Yeah. Yeah. Okay. Okay. Now, it's out. Mhm. have to resew some leg because I have to resew some leg. Then test. Okay. Yeah. Think okay. Yes. You're getting there. Okay. Allow the board to cool down for some minutes. Just let it cool down. So we have yeah. You can test it now. You can test the board. Good. Job. I'm sorry I lost the second camera, but you can see it on the power supply. You can see the current, and you can see now we have 2 amps, 2.4 amps, which is correct charging current that I'm expecting. Sure 100% the laptop is charging now. Yes, it's charging 100%, and that's it. So our problem is the charging IC, and you can see how we narrow down to the main problem. So you have to check everything. And make sure every step is completed before moving on to the. Now let me confirm this pin 18 and 17 now and see what footage we have there now, because before we are having 15.5 on both 18 and 17, and 15 we don't have anything before. Now let me check and see. Oh, sorry, you cannot see my multimeter, but I will tell you the following. We have 11 volts on pin 17, and pin 18 we have 14.6. Yes, 14.6 on pin 18, and on pin 17 we have 11 footage. Correct. And before we have the same footage on both pin before, but now we have different footages. So now the laptop is charging, and that's it. And pin 15 before, we have 0 footage there. Let me check it now. Stay the same. Oh no, yeah, no footage. We have 0.30, no 3.30, no footage from the low side. Low. Okay, that will be all for this video, and thanks for watching. Like and subscribe to follow this channel and to get notified whenever we drop another content. Thank you.